What you're looking at is the beginnings of our compost barrel thermometer. It's going to be about 1/2 meter long. Have a readout of the temperature here. It's using an Arduino Nano made by Gravitech here in Thailand. That's the brains of the operation, and then this is the actual sensor. So the sensor is going to go at the bottom of this PVC, and then ahead of it will be a spike to push it into the barrel, into the compost, right into the heart of it. And then the lines will come up and connect it to the Arduino and the LCD screen here. And right now it's being powered by a power bank, just for show, but we're going to use a 9-volt battery. We're going to also incorporate this switch. And we're going to try to design it in such a way that it's not that hard to change the battery when necessary. On the back of these LCD screens, there is an adjuster right here to adjust the brightness of the screen, and sometimes that just changes over time for whatever reason. So we're going to make that accessible in the design as well. Now, the whole point of this compost thermometer, checking the temperature inside of our compost barrels, is to help out a process called hot composting. In previous videos, I said the composting that we're doing using waste from our chickens, we have 4 egg-laying chickens, that could take between 6 to 9 months to fully break down and be usable for your garden. But as I was doing research on this, I found out a process called hot composting, which can reduce that down to maybe 2 or 3 months, which will be really great. And it'll cut down the number of barrels that you need sitting around curing to make compost available to our vegetable and fruit garden, our container garden that we're also setting up. So in order to do it properly, the temperature needs to be around 130 to 140 degrees Fahrenheit, or about 55 degrees Celsius or above. And so to make sure that it's being done properly, we're going to build this thermometer. Now, I said we were going to use 3D design and 3D printing and open source electronics on what was otherwise pretty traditional farming infrastructure. And so this is an example of how you can do that. So we need a very specific custom-made piece of equipment. We've got a 3D printer, we've got open source electronics, so that's what we're going to put together. And we'll give it a try, and we'll see how much this helps make this process of hot composting more consistent, more efficient, and help us understand the process more clearly by being able to track the temperature inside the barrel. If you thought this video was useful, please like and share this video. Please subscribe to our channel. That helps us out a lot. Check the video description below for any extra resources we might add in. When this particular project is finished, we're going to upload all of the designs onto Thingiverse for free. So if you have a 3D printer and you want to make this thermometer, you will be able to, and we'll have the plans step by step to follow in order to do that. If you really believe in what we're doing here at the Applied Technology Lab, in the video description below, there are also ways you can help support our work. That is greatly appreciated. The more resources that we have, the more projects we can do, and then the more we can release to the public for free, because that's what we do. Once we figure this out, everything will be uploaded to different platforms for free for people to use. And as always, remember, knowledge is power, but only if you apply it.